So welcome, and I'm going to hand it over to you, Dave. Thank you very much.
Great. Thank you, Caroline, and thank you to CLF for hosting this event today. My name is Dave Ramsley, and I have the pleasure of facilitating this launch of the Pragmatic Approach to Lowering Embodied Carbon Guidelines. I just want to note off the top that I have nothing to do with these guidelines. I get to appear alongside these very smart people who did, and hopefully have some of the credit rub off on me in some way. I'm really excited to introduce our panel here today. I think these guidelines are extremely valuable. Myself, having worked with owners who are very passionate and want to find ways to reduce the embodied carbon of their projects, but for whatever reason, whether it's site or program or the team that are there, and the lack of familiarity with maybe mass timber or wood, which is what we typically associate with low carbon. There's a real need to figure out how far we can really push concrete to lower these embodied emissions. And I know that there's a real hunger in the market for this, as evidenced by your interest here today. And I just also want to salute the panel here. This is the culmination of years of work, over your work to bring these to completion. So before we get into it, I would also just like to acknowledge and note my thanks that we are having this meeting on the ancestral and unceded territories of the Musqueam, Tsleil-Waututh, and Squamish nations. We thank these nations and their ancestors for the privilege of living and working on these beautiful mountains, fjords, and plains. And to give you a rundown of what's going to happen today, in a moment, I will introduce our esteemed panel, but we're going to kick off with a launch of with a brief overview of the guidelines themselves. That'll be about 5-10 minutes, led by Ian. And then we've reserved the majority of the time today, about 45 minutes or so, for Q&A for the panel, where I'll be grilling the panel on different aspects of the guidelines. And for those of you who are in the room today, we'd like to keep this a lively discussion. So if you do have questions for our panelists that come up in the discussion, if a question prompts your question, please just raise your hand, and we will we'll just answer it as the event unfolds. And we will have time, as I mentioned, about 15 minutes at the end to also, if there's broader general topic questions, we can take those at that time as well too. I think Caroline mentioned it, but this is a hybrid event, so partially online, partially here, and 100% awkward for everybody. But welcome to 2023. And if you are at home in your sweatpants, well, you really should have made an effort. And I hope that you're asking some serious questions about yourself, and and your choices, the choices that were made. Anyways, but we will take your questions. Please put them in the chat, and we'll pose those at the end of the session. So without further ado, this is an excellent panel because they're not just experts, but they also represent the key players that you'll need on your team when building a low-embodied carbon concrete project. They represent architectural design, structural engineering, construction, and concrete suppliers. And I'll kick it off with introducing Ian McFadden. Ian's a principal with ZGF Architecture and leads their building performance group. Ian supports client teams in realizing the opportunities for cost-effective and project-specific sustainability outcomes. Just on your right middle is Jolene McLaughlin. Jolene is the Vice President of Climate and Sustainability for EllisDon, the EllisDon Corporation. She works to build partnerships across the industry that support carbon emissions reductions through the value chain, from materials used to the on-site processes and operational energy of those buildings. Next to her is Matt Delkey. Matt has worked in the cement industry for his entire career and is currently the Senior Sustainability Manager for Lafarge in Western Canada. Before this position, he held engineering positions in manufacturing plants and technical centers in New Zealand, the United Kingdom, France, and Canada. He has a detailed knowledge and understanding of cement manufacturing and the production of concrete and concrete products. And last but not least, we have Yuri Kulikov. Yuri is a structural engineer and has extensive design experience in recreational, cultural, and residential buildings. He strongly believes that structural design plays a key role in the reduction of the construction industry's carbon emissions. At Fast+Epp, he leads the firm's sustainability initiatives, including the implementation of the Embodied Carbon Action Plan. So without further ado, I'm going to introduce Ian to walk us through the guidelines. Ian.
Thanks, Dave, and welcome everybody. As Dave alluded to, this has been the culmination of a good couple of years working off the side of our desks. So the four individuals here, and a few other individuals here, Ashish Kamchandani, Vicky Sue, and Marie Bednash were kind of fundamental to making sure we got to where we are today. So big thanks as well. And I would also ask that if I'm missing something through this introduction, jump in, because we have been at this way too long. Oh yeah, for sure. Sorry about that. Now you got to hear my Glaswegian. Full bore. So we have we soft release of these guidelines earlier this year in about June time, and the idea of having a soft release was we're able to get some feedback from industry leaders in the area. We managed to get some feedback from local authority, government agency, as well as certification bodies and some developers. So these guidelines have now been kind of brought together with some pretty fulsome feedback, and hopefully you guys will find them useful. Next slide, please, Dave. For sure. Is there? Okay, am I gonna have to eat this? Okay. Oh, my kids would love this. It looks as though I'm eating an ice cream. So, but just giving a little bit of context in terms of why we are where we are. So if we take a little bit of a step back, we're now talking about carbon and total carbon. And we've got here through a number of years of kind of understanding with regards to energy. So energy costs, say about 10 years ago, that then migrated into EUI with the BC Energy Step Code. And with that migration to EUI, it was a very quick transition into discussion around operating carbon, which is the light blue that you see there. With that discussion on operating carbon, then the question came from design teams, well, what are the other impacts that we're seeing on our projects? And that really is that blue component that you see, the darker blue. And as we've migrated through time, so the one pie chart to really concentrate here on is the one that's furthest to the right-hand side, the smaller one. As we've moved to higher performing buildings, and they're connected to low fossil fuel grids, which is really what we've got here in Vancouver, then embodied carbon starts to play a much bigger role. And that was kind of the context where we kind of started this out on with the kind of approach around embodied carbon. Next slide, please. And working with our design team members, so structural engineer, as well as contractor and concrete supplier, we kind of really started to understand that concrete plays a significant role in the human-made GWP or human-made CO2 impact associated with our lives. So ultimately, 8% of everything that we generate from a CO2 perspective is from concrete. And from that perspective, working with structural engineer, contractor, concrete supplier, it was pretty evident very early on that there's a lot of low-hanging fruit that we can build into all of our projects from the outset. Next slide, please. And really what we're trying to do with these guidelines is to really optimize the decision-making process. So when and how do we make the decisions to maximize the benefit of low-embodied concrete design decisions? That's really the idea of lean design process. So minimizing the redesign through projects, and really leans in on this idea of collaboration and integration early on from design team members and the construction team. With all projects, maybe not necessarily all projects, but we should definitely consider the idea of building nothing, reuse and repurpose our buildings, which is kind of right at the outset of any discussion that we should be having as portfolio managers if we have got a portfolio of projects. When we're starting to navigate through new construction projects or redesign or reconstruction of projects, there are a lot of efficient structural systems that we can bring into play or decisions that we can make through the schematic design and design development. Things like TDM measures. So what can we do to minimize the amount of parquet that's going into our project? Also having full geotechnical assessment of our sites so that structural engineers can design a structure that responds directly to the need of the site rather than having to use rules of thumb. The guideline outlines a lot of these or all of these elements, and we've got very technical components that break down each of the kind of structural systems. Last and definitely not least is optimizing the concrete mix designs. So if you're all sat here today and you've got projects that are in CD, you still have opportunity to have an impact on your projects. Next slide, please. The interactive guide at the center of this is what we've kind of called the fulcrum to the document. This is a landing page that you can come to, and from there, if you toggle on the blue, if I had my mouse in front of me, I'll be able to show you. But each of those bubbles, there's a blue component as a header for each of the bubbles. And if you land on those, it'll take you direct to that section within the interactive guide. So you can self-direct your review of the documentation. But within those sections as well, there's a header bar with the interactive guide in a stronger format that leads the reader to track you back to this fulcrum of the document. It has been laid out to be read sequentially as well. So if you're like me, you need something that's not as interactive, then you have that concept as well. What we've also tried to do is identify the key team members that should be part of that decision-making process. So you can see at the bottom of each of those bubbles, we've identified the key team members. But what I would say, optimizing that decision process is bringing in the team as early as possible. So if you have the opportunity to bring contractor and concrete supplier, then do it. And that's been some of our biggest successes of our projects.
And I think I'd add, if you don't, because your contract doesn't allow, still find a way to bring them in early anyway.
There are ways.
You were talking for too long.
Yeah, no, it's good. Thank you. Again, I was talking too long. Next slide, please. And this is an example of some of the bidding forms, or what I should say. There is a bidding form link that's in the specification and procurement section. And we've provided an example of one of the projects where we've used this on. This is really going to test my eyes. So the way that we walked through on this project was understanding from the structural engineer in terms of the elements on the project, what the different strength classes, and from that, we were able to navigate through using the BC concrete guideline and understand what the baseline would be. So that baseline is just after the blue column. And we were testing ourselves or looking to improve beyond that baseline. So again, working with a structural engineer and where possible, the contractor and the concrete supplier to understand what the target would be. And the target is that percentage reduction target, which is listed at 21%. And this is what we use as an overall target for reduction. We're trying not to be prescriptive, but performance-based with the strategies. Next slide, please. And Julian will be happy. I'm kind of wrapping up after this slide. So we've got a section that kind of just starts to touch on embodied carbon life cycle analyses. There are a lot of tools out there to support with full life cycle analyses. You see 3 one-click and Tally, and there's TallyCat that's coming on the market in the near future as well. These are full documentation tools that are needed for AHJ requirements, authority having jurisdiction, when they have embodied carbon targets, as well as certifications. But the example I showed you before is something that we can use as direct applicable analysis that really rapidly allows teams to identify what the opportunities are with projects. So in that previous slide with the procurement slide, with that example, it took us 2 to 4 hours to develop. And then from there, we're able to have really direct conversations with the design team, as well as the client, in terms of what the real opportunities were. Thanks, Dave.
Great, thanks, Ian. So now we've had an overview of the guidelines. So let's dive right into our panel discussion and questions here. The first one I'm throwing out to Yuri at the end of the table. So if you want to reposition your mic, Yuri. We've probably a pretty savvy crowd here, but for those of you who may have the terms conflated, what is the difference between embodied carbon calculations and life cycle cost assessment?
Thanks, Dave. Can we go back actually to a slide that shows the life cycle? So building, yeah.
This one?
One forward. One more forward.
There?
The last, yeah, one more. Here we go.
There.
Nice, thanks. Yeah, as Dave said, it could be trivial for some of us, but I think it's important to make a clarification, because we do hear about life cycle analysis a lot, and that's the term we're familiar with, which is usually done, by specialists. But we're concerned about embodied carbon specifically in this guide, and those calculations can be typically done in an easier format and by a lot of consultants on their own. So, in short, basically life cycle analysis is a more complicated, bigger process that includes embodied carbon calculation, and embodied carbon calculation is a part of life cycle analysis. Life cycle analysis explores multiple environmental impact categories, global warming potential that represents embodied carbon. It could be acidification, ozone depletion, and a few others. It also considers the whole life cycle of the building, starting from product stage, construction, use, and end of life. When we talk about embodied carbon calculation, we concern only about one specific environmental and impact category, which is global warming potential, or GWP. And then most of the time we are addressing calculation on the product stage, especially during the design. What's important to understand, it's not very complicated software can do the embodied carbon calculation. You can do it by hand. You can do it very quickly as long as you know the quantity of materials, and structural engineers can take care of their own scope. Architects can make their own scope, which helps them to make the decisions. You do not need to have a special, in some projects, you do not need to have a special consultant to run the whole full cycle analysis, which could be helpful and has its own use. But those are that's the difference.
Great, thanks. I'll just throw over to here. Getting back to the beginning, I know you kind of touched on this a little bit in terms of how you guys set your baseline, but maybe throwing back to Ian here, how do you set realistic baselines and targets?
It's a good question. Hopefully you guys can hear me rather than having to eat this thing. It has to start at the outset and really understanding the overall goals for the project. So putting embodied carbon into context with regards to the client's aspirations, stretch goals. Once we kind of understand that if there is an embodied carbon target on the project, then we can quickly start navigating through the contribution and potential contribution and impact that low embodied concrete can have on a project. The example I gave earlier is something that we use kind of on all of our projects. The bit that I think is interesting when it goes wrong. And so we always start off with the idea that we can use these processes and it's going to work on every project. But we actually had a project where, sitting down with the design team, they said there could be absolutely no positive impact with regards to embodied carbon of concrete because of the fast schedule. The project just had to get constructed as fast as it possibly could. But sitting down with the design team and actually understanding what the pinch points were, we're able to translate those pinch points into performance metrics. As soon as we were able to translate those into performance metrics, we were able to ask for a response from the contractor and the concrete supplier in terms of what the optimal mix designs would be for each of those different elements. And what it transpired was the slabs, go figure, development, residential development had to be constructed very, very fast. So we had to deal with 3-day stripping strength for that component, but there were other opportunities with other areas, foundations, the core, and other components. And what transpired was we were able to get a savings of 10%, no cost. I think it was 20%. There was a cost component to it, and then 40% was the max, and there was a cost. But just by walking through that process, we were able to really daylight what the decisions were from the client perspective.
Great. Maybe just I might take the chair's privilege here and just say, what was Ian and maybe the rest of the panel, what is driving you to have to set these targets? Is it clients? Is it regulation? Is it you doing advocacy as your roles as service providers? Where are the targets coming from? Where's the heat coming from?
So it's a combination of factors. We're seeing it coming through with AHJs recently. City of Vancouver releasing their guidelines, but we've, as ZGF, we've been pushing for this over the last few years, and really just starting to highlight that with embodied carbon, there are some really easy decisions that can be made and have no impact on cost, especially when it comes to concrete. And that so that advocacy has been going on for a couple of years, which is one of the reasons why we're here. We've been able to be, push clients down a certain path at no additional cost.
Yeah, so I would say for us, it's the combination of factors like Ian mentioned. We have clients who have, similar to us, set science-based target commitments or other climate change commitments. And so there's a piece of us advocating to try and find ways to reduce emissions. We've got an internal R&D team with, I think there's 6 concrete specialists specifically who understand concrete science more than I even knew it actually existed until recently. And so they've been working on improving the performance of our mixed designs. And oh, by the way, sometimes they can also reduce the embodied carbon. So now their mandate is let's improve the performance and also reduce the emissions. And then we have clients coming to us saying, we want these teams on this project so we can make sure we reduce emissions. Yeah.
And then from the cement and ready-mix industry, Joe mentioned the Science-Based Targets Initiative. As an industry, what was raised before, that we're contributing approximately 8% of the world's anthropogenic CO2 emissions. And in Canada, that's actually about 1.4% of our total national emissions associated with cement production. So there's a lot of pressure on us as an industry to reduce our CO2 footprint. And we've been working on that basically since the inception of the Kyoto Protocol. So way back as far as 1990, but that pressure is really increasing on us as an industry when we're starting to see investors make investment decisions about which companies are going to invest in, how much they're going to invest, how they're going to invest. So those impacts and those influences are actually coming right down to the operational level as far as our industry and driving to reduce our embodied carbon of our products. And as Ian was mentioning before, going out and advocating for those reductions with specifications, with standards organizations, with building codes and things like that to allow us to actually have those deep carbon reductions.
Great. Yeah. So there you go. Didn't know I was going to be throwing curveballs at you, did you? But being behind you, anything can happen, right? You don't know what I'm doing back here. Okay. The next one I'm going to go to both Yuri and Matt for, and it concerns, what are the easy wins that that design teams can achieve in terms of material efficiency and actually using design as a strategy to lower embodied carbon?
Yeah, I think I'm gonna start here because this is where we start first, right? The initial low-hanging fruit, initial goal here to reduce the volume, right? Once we reduce the volume, then the second step we start to using materials that are better, but the initial goal is not to use as much material as we can. And that's very important to understand that majority of what we can do right now as an industry, as engineers, designers, is to reduce the volume to make our designs better. What are the top 4 low-hanging fruits? In my opinion, number 1, it's investigation, geotechnical investigation and analysis. Number 2, optimize foundation design. Number 3, but maybe number 1, more efficient structural layout and architectural layout. And the last one is prefabrication. When we're talking about investigations, a lot of the time, when we have more time, spend more effort, we can get a better information from site, higher resistances, which means that the foundation is going to get smaller. Once we get into foundation, there is a tendency in the industry to use sizes and elements that are repetitive, and we're trying to minimize the number of different sizes. Well, we should start shying away from it and designing things specifically for what needs to be designed. You know, if we used to specify 10 different footing sizes, I'm not saying we should do, you know, for every single column, different one, but let's do a bit better job. Let's do 20, 30 different sizes. Structural layout is huge. We know that up to 50% of embodied carbon of the structure, and structure could be up to half of the whole embodied carbon of the whole building. So half of its structure and half of the structure, between 30 to 50 of the structure can be within slabs. So that's the first thing where we need to target and reduce the thickness of slabs by having efficient concrete, in this case, column grid. By efficient, it should be spaced appropriately, and it also should be repetitive as much as we can. With that, also eliminating transfers. We know that the transfer elements take significant volume of concrete and steel. So let's line things up throughout the building. By doing that, we can achieve 20-30% reduction. So that was number 3. Obviously, prefabrication leads to significantly less waste during the construction, or let's say production processes, and eliminates unnecessary energy during the construction site. Now, the last one is could be still hard to quantify, but inherently it leads to significant unnoticeable material reductions.
Well, what I would add to that is during that schematic design process, that's your first opportunity to start engaging outside of your normal design scope. So it's your first opportunity to engage the potential contractors that you may be looking at, to understand what the schedule implications are, or if you're coming up with a different design, how they're actually going to construct that. But it's also your opportunity to start engaging with ready-mix suppliers to understand what options there may be for say high strength concrete to make reduce the volume of floor slabs or columns, for example. So understanding what is available in the local market for a specific project and how that can influence and impact the design that you're looking at.
Great. Great advice. Well, I think we're going to move into the
This is an example of that.
oh yeah, no, go ahead. Speak to the diagram.
The diagram. So this is kind of just highlighting one of the projects that we have been working on in terms of concrete volume reduction. This is a multi-unit residential project in downtown Vancouver, and we are working with the city of Vancouver in terms of a case study. And this just really shows the impact of what Yuri and Matt are highlighting. We're able to reduce the parkade level only by 1 level. There was only two parkade levels, but we did that through TDM measures. And we also looked to relocate the mechanical system from the parkade onto level 1 and the roof as well. And that had a 9% reduction on the overall LCA for this project. So not just an unbounded carbon, but it has a significant impact in terms of the overall LCA for projects. The other component that we looked at in terms of volume reduction for this project, which really outlines what Yuri was saying, optimizing the unit layout and stacking as much as possible really can mitigate or reduce the need for transfer slabs. And that stacking of units has knock-on positive effects from personal experience working with a mechanical engineer and the electrical, minimizing those runs leads to an awful lot of less hours worrying about clashes. So, you know, there's a positive impact right across the board.
Yeah, and so one other thing to point out on the volume reduction side, that also means cost reduction because we're not paying for extra material we don't need. And then that efficient design and layout means it's generally faster and easier to build as well. So there's knock-on effects that are well beyond just the 9% that is shown.
Can I make a comment? It just sounds like we're talking some, very simple, trivial ideas here. Everyone knows it.
Yeah.
But these are the most important thing to do, and we're trying to emphasize we need to be doing this, not only be talking about it. I think that's my personal takeaway.
Well, I think to Yuri's point, it's simple and easy to say, but it's not, because it's not the traditional way we've been building projects. Everybody's been in the 4 buckets that are here on their own instead of trying to work together. And that was one of the biggest things we wanted to do with these guidelines, was say, when the 4 of us work together, there's so much opportunity that we end up leaving on the table if we only do one half of the table or the other or whatever.
Yeah, and from the ready-mix producers perspective, traditionally our engagement has been during bidding. Sometimes even after the GC has been let. So that's really late in the game to really have a big impact on carbon reductions. So sometimes we'll get the question of, well, how do you want to engage us as a ready-mix industry? When do you want to be engaged? As early as possible is really what it comes down to. And that may be from the perspective of the architect, it may be from the engineering company. Reach out to your local ready-mix suppliers, start understanding what their capabilities are, what the options are that you have available to you, and that helps inform your design.
Great. Well, sticking with you, Matt, word on the street, and I don't know if it's a myth or not, but is that there's not enough slag or fly ash available. Am I right? Are my sources correct on this?
Partially right. Okay, so the guideline is really focused primarily and was developed primarily with the lens of looking at the Lower Mainland as the location where it's most applicable. But really, when you look into it, a lot of the concepts that we've just been talking about are concepts that can be applied anywhere. It doesn't really matter where the project is. What is more important as far as the specific location of the project are the materials that are available in that location. And the 2, what we call supplementary cementitious materials, are slag and fly ash, have been the traditional materials that have been used here in the Lower Mainland. Some of those materials may not be available for certain projects in certain areas, so that's something to bear in mind. Fly ash, for those people that aren't engineers like myself and have dealt with this sort of stuff for decades now, but fly ash is the byproduct of coal-fired power generation, and coal-fired power generation is shutting down if you've lived under a rock for the last 20 years or so. So that means that as those coal-fired power generation is shutting down, that fly ash is becoming more and more constrained as far as being available for the production or to go into concrete. Thankfully, there are other options available for us. So a lot of fly ash was actually impounded either in landfills or impoundment ponds throughout North America. And it's estimated that there's somewhere around 2 billion tons of material available that can be harvested, treated, and made into a material that behaves in pretty much exactly the same way as fly ash. So those sorts of projects are coming online in the next few years where and some projects have already been online as far as recovering that material and producing a material that can be used in concrete. So there may be an immediate and short-term constraint, but longer term things are looking a little bit better. For slag, as a byproduct of steel manufacturing, it's from basic oxygen furnace manufacturing. So taking iron ore and then putting that in a basic oxygen furnace to produce pig iron, which then goes into steel production. As more steel producers are switching over from basic oxygen furnace to electric arc furnace production, that means that that slag that comes out of EAF systems is not currently suitable for use in concrete. It's only the BOF slag. So as producers are switching over, that means that there's less of that slag that's going to be available. The expectation at the moment is that longer, even in the short to medium term, there's still a substantial amount of iron that will be produced through the BOF system. So although there may be an increasing demand as far as using that slag in ready-mix concrete, couple that with less being available, it looks like there will be a point there where we will run out of slag, but that's not happening in the immediate future.
Yeah, so I would say the key to this question is we can get by with the slag and the fly ash we have now, but we also have to be innovating how other ways to reduce that cement content and reduce the emissions intensity of the cement in general. And I know Lafarge and others are working on lots of different types of investigations, but part of the hurdle there is code and regulations and standards allowing products that aren't currently listed as SCM to become SCMs.
Yeah, so there, as Jolene said, there are other materials that are being looked at, such as natural pozzolans, which harks back to Roman concrete, but also other recycled materials such as ground glass as a pozzolan. So there are certain restrictions in codes and standards that potentially limit the use of those sorts of materials. So as on the advocacy front, that's another piece that the industry is working on to make sure that those codes and standards evolve to a point where they actually allow the use of those materials as well.
Well, sticking with that, actually, while we're talking about SCM,
Dave, Anthony has a
ooh,
question.
we have a question. Anthony Pack, what's your question?
You mentioned the short to medium term, likely. What's short to medium? Basically, like I heard also for the fly ash, like that was on the order of like 100 years or something on the landfill capacity. So on the slag side, what do we have right now? And then also, are there similar stockpiles in landfills? And then the third piece to that is basic oxygen furnace. Like that's for producing primary steel. Right? So we still need to produce primary steel. So even in the low carbon variations of the primary steel production, we still get the slag that we need from that.
There's a lot. So yeah, so the landfill fly ash is expected to be decades or as you said, 100 years. Not all of it is suitable to be able to be recovered and used for concrete. So although there's a large amount of material, alternative is a question. As far as the short to medium term for slag, that's really in the immediate next 5 years. From iron ore. So yes, unless their system changes entirely, that will still produce slag that will be still suitable for use in concrete. Now, there are, as the cement industry is looking at reducing embodied carbon and our CO2 emissions, the steel industry is looking at the same sort of technologies as well, or the same end goal.
of producing a steel that doesn't have embodied carbon associated with it. So will their systems and processes change? Certainly. What that means as far as slag availability for use in concrete, we don't know yet.
Is this more just a localized issue like that? North American steel mills are moving to EAF steel, but like in Asia, they still because they still have to produce enough primary steel, not enough recycled steel.
So
Right.
We're diverting.
Oh, sorry.
I've been in conversations with a couple of steel producers and they are moving to DRI, EAF.
Yeah.
For primary more so. I don't think that means that BOF goes away entirely.
Right.
But I think the ultimate point as it relates to concrete specifically is we have to still find other solutions. We have solutions for now, but we can't just say, okay, we're done. This is gonna solve the problem.
Yeah, I mean, fly ash, as I said, is a constrained resource. There are serious limitations as far as its availability today. Slag is somewhat constrained. There is more available, but there may be some specific local issues as far as its immediate availability.
Thanks.
Great. Well, I think this is a very related question, and maybe throw it to whether it's Julian or Matt first. Does increasing supplementary cementitious materials, SCMs, lead to schedule delay?
So the impact of adding SCMs to your mix does impact how it gets cured.
We've been really successful in using high volume cementitious material, supplementary cementitious material, too many words, to reduce the embodied carbon while improving the performance. That does mean that sometimes you don't get the 3-day strip strength that you need. So you have to pay attention to the schedule. Often we use 40% plus in our foundation systems because they aren't on the critical path. We have a bit more lead time. Ian mentioned already on slabs, because they're such a fast cycle, because everything in the schedule waits on them, we can't necessarily go as high. And so the answer to the question is yes, it does, but you can mitigate it by managing it appropriately. And another tool that we're really looking at is in situ monitoring of the strength. So sensors that tell us how strong it actually is after 3 days. So we know we can strip, maybe it's at 2 days, maybe it's a day and a half, just depending on how the actual mix itself performs, instead of waiting on the old rules of thumb that we've had to use for years. That comes back to getting CSA adjustment as well, because there is requirements for strip timing written right into CSA.
And this is definitely the sort of discussions that you should be having with your local ready mix producer, because different SCMs behave differently in concrete. Do they have different availability based on, as I said before, the specific location of a project? So when you're actually working with your local ready mix supplier, this is really your opportunity to understand what options they have to impact the embodied carbon of the concrete that is being supplied, and what implications that may have to the schedule. The earlier you have those discussions and understanding what the potential schedule impact is, that allows the contractor to arrange the work schedule in such a way that it minimizes the overall impact on the construction.
So yeah, first takeaway, make sure you get Julian on her job as a contractor to get the conversation going. If not, then we as engineers learn to open this conversation early and do not take the answer as saying, well, it's gonna make things longer and we don't have time for it. Okay, let's talk about what do you actually mean? Let's get into details. Which elements, what schedule can we work around it? I think having that conversation rather than taking no as an answer, that will get us a long way. That's a personal experience from working on the project.
Yeah, I was thinking before that this is a little bit like where LEED and green construction was a few years ago, where you get right to the end of the design and they say, okay, well, let's make this a green building now and let's go for LEED Gold. And nobody was really thinking about that through the entire design process. And I was like, okay, well, that's the wrong way to do it. Yes, there are opportunities right at the end of the project but having those conversations early, and I know we keep saying the same sort of things in a different way, but engage early gives you the best opportunity for a good project outcome.
Yeah, that's what I was going to say too. Normalize having these conversations and really understanding where the schedule constraints are in this situation, or all of the other questions that there are. Make sure that we're all kind of on the same page and learning. Marie? I think that it doesn't, because the answer is early, just as early as possible. One of the upcoming question talks a little bit about that bid form that Ian had showed up earlier. And the way we try to engage earlier is as soon as we're asked to start tendering the project or start investigating the project, we reach out to our concrete suppliers and give them, here's all the mixes, give us your cost, your schedule pricing, all of that stuff that you normally provide, but then also tell us what the embodied carbon is. And it's not because we want that's going to be the end answer of the embodied carbon impact of the concrete. It's because that starts the conversation, that allows us to investigate options, and it starts to normalize this whole discussion and keep people engaged early.
I might just contradict, which isn't normal for us. But in that interactive guide, there's actually that what we're trying to do is outline the sweet spot as to when and how to make the decisions. And so that interactive guide is the kind of, if you're coming at this fresh, never looked at this before, that kind of acts as a very, very good guide in terms of when to optimally get the individuals in space. We as designers don't always have the opportunity to bring in the contractor, the concrete supplier as early as possible. But what we have tried to do is to say, this is the key decisions you can be making through the project phase. So that's my contradiction.
And I think it's fair to say that too, because we don't always get to bring in the suppliers as early as we want to either. But the point is to have the conversation early so everybody knows that embodied carbon reductions is a key goal for the client and the project overall.
And it does depend on what the question is. So, like, sometimes we've been brought into conversations at the early design stage, and from just a conceptual design, saying this is what we're thinking. Is this something that can actually be done, or what's your input as far as this particular design choice versus this one, and what would actually happen as far as the concrete that you supply?
Great, we've got a question up here in the corner. My question's for Matt. So when we're engaging early, provided we've done on the design side some level of effort to arrive at a target, is it more useful to get a total budget for the emissions of the concrete, or is it more useful to have per element targets, like per column, per slab?
Can I just say, Jeremy,
Repeat the question.
is it better to have a target per element or roll it up to one overall target?
Or from a supplier.
So from our perspective on the design team, we do by element, but then we roll it up to percentage reduction target. But I can tell you that's been a huge debate even in this year. And so depending on who you ask, you might get a slightly different answer. From my perspective, work the detail, but then roll up to an overall percentage, because I think we're still in the infancy of really understanding the impact, and that's where the fight's been.
Well,
That's not stabbing me under the desk yet.
it's because I'm over here, you're not getting it. The real issue is the construction schedule is constantly changing. If we are held to, you can only have this amount of emissions on, let's say the slabs, which are a critical path item, and something happens, because it always does, and we can't get there, then we're sacrificing schedule, which often means more money for owners. And so if we understand the detailed roll up, but then get the roll up as the agreed to target, that gives us flexibility to say, you know what,
This section of slabs we cannot do anything on, but over here we're going to change something else.
I guess from my perspective, and we just specify things and we walk away. I'm just curious, we trying to do the best we can do, right? That's the goal per element. The idea of having overall budget is saying, well, if we can't do good of a job here, you kind of have it now opportunity to not doing the best you can do at some other elements. And if you cannot, then you can't. So that's my perspective. You set a target for each element, and if you can achieve it, you will achieve it. If you're not, then you can't.
So
I'm gonna move us along here just because we are. And this one's a whole panel answer anyways too.
Yeah.
So you guys are gonna get to speak, but
this is actually.
and this is where I think, yeah, it's a good bridge. Yeah. So how do you effectively communicate carbon reduction requirements through the construction documents, whether those are element by element targets or overall?
Sorry, Dave, but the question was to supplier actually, and everyone spoke up except the supplier. Maybe Matt a few words to share.
Yeah.
Sorry.
Just briefly, having an overall carbon budget for the entire project is what makes the most sense from a supply perspective, because that gives us as a supplier the flexibility to work with the contractor to understand the real minutiae around the schedule impacts of a particular concrete supply.
The reason why I don't like Yuri's answer, because we are contractually obligated to meet certain targets. And so if that comes in as a contractual, when we're talking about it as, okay, here's what we want to strive for, let's all do it, let's see where we can go, that's all good. But often we come against a contract obligation. And so I think you have to understand the engagement between the team. If it's contractor, you must do this thing, then you've got to give us some latitude. Otherwise, one of the things is going to give. If it's everybody, let's work together and do the best we can, then it's a different conversation.
And that happens with concrete as well. We get different specifications saying this concrete needs to do this, this, and this.
Right.
And it's like, well, this one conflicts with this one. So you've got to make a choice because you can't have both.
Yeah.
And when you bring CO2 or embodied carbon into that conversation as well, that's just another metric that you have to balance out and try and figure out what the impact is going to be of certain choices.
So it all comes down to performance.
Yeah.
Not prescriptive. So we've been talking about all the potential solutions, fly ash, slag, all those kind of components. But really when we're setting up our specifications, we want to be having the performance targets for the project without dictating what material needs to go in there. And that allows a level of flexibility for the contractor and for the concrete supplier to respond, whether it's schedule impact, it could be a new innovative SEM that none of us have ever heard of. I know for damn sure that's not my area of expertise, and I want to rely on Matt and his team to respond to that mix design. What makes the most sense? The other component with specifications is ask for EPDs, environmental product declarations, within the specs at every single point. The more that we can get the information across from concrete suppliers to help us understand really what is being developed with these mix designs is just going to help the knowledge base of the community as a whole.
I'm going to ask a question here that came to us from one of our viewers at home, and they were talking about specifically on targets. This question from April Wang, and she was wondering, is it better in the construction documents or specifications to specify things like percentage of SCM, or is it better to specify, in your opinion, an overall embodied carbon goal? It sounds like the latter, but I just wanted to confirm that. It's a question from the panel.
Overall embodied.
Yeah.
Yep.
Touching back on amendment or aggregates that are in the mix, the fibrous material that can be included to reduce or strengthen flexural and compressive strength of the mix. Does that displace cementitious material? Does that help for lowering the carbon impact?
That's for me.
Yeah.
So the question, just to make sure I got the question right. So you're asking about fibers that can be used in concrete to improve either the
Flexural and compression strength.
and flexural strength. There are
That allow you to diminish the amount of.
Can you diminish cement as a result of that? There are a number of different types of fibers that can be used in concrete, and they have different impacts. There's a steel fiber, for example, that can be used to eliminate traditional reinforcement, for example. There are some technologies that are coming into the general market now, such as using carbon nanofibers, for example, nanotubes, for example. The evidence so far is showing that yes, they can increase, particularly when you're looking at carbon nanotubes, they particularly increase the flexural strength and can increase the compressive strength. So it depends on what's the development that you're making. Some of those are relatively early as far as their availability and their adoption in the market. But it's definitely something you should be exploring with your ready-mix suppliers, you know, what they have available to them, what they've worked with in the past, what they have experience with, and understand from that experience what gains there may be as far as those strength improvements. And from that strength improvement, how much cement they can actually cut back on that.
Thank you.
I was pretty sure the question was for me, but no, thanks, Matt. I think once you start, I just want to notice, you know, low-hanging fruits. You know, flexural, we're getting, you know, it could get complicated with fibers from engineering perspective. Definitely explore fibers for things like slab on grade, where reinforcement is dominantly to deal with shrinkage, or vertical elements like walls, predominantly in compression. We're talking about concrete today, but we're kind of jumping into reinforced concrete and addressing the second part of equation with reinforcement. So by adding fiber, we can remove some of the reinforcement. And you do this, if you could do this quick analysis, how much volume of fiber you need per meter cube versus reinforcement. For, let's say, slab on grade, you might achieve significant reduction in the overall steel. So that's another reduction to your overall final product. Yeah.
Okay, we'll take one last question here from the audience, and then I'm going to hand it back to Caroline to wrap up for today. And those of you who have questions online, what I'll do is I'll take these notes down and see if our panelists will get back to you, or maybe how would we actually get back to them? We could keep the chat. Sticking around for another 5 minutes. Sure. Okay, we'll go for another about 5-10 minutes online after this. Okay. Question.
The elephant in the room, what about cost? I know we talked about volume of concrete and how that can impact costs. As a designer, having conversations with clients, there's often this, oh, but that's going to cost more. We are starting to see that on a few of our projects, that suppliers are saying it's going to cost an extra blank percentage. So I'm interested to hear from the middle of the panel, tracking concrete and tracking embodied carbon in the process, and the conversation that happens between the supplier and the builder to meet this overall embodied carbon target for concrete. How much does that impact your cost of your service offerings for building?
So I think one of the more frustrating things for me is I've been in this industry for 15 years or whatever it is. Everybody assumes that if it's more sustainable, it's going to cost more money. That doesn't have to be true, but there's a lot of times when people try to take advantage of, well, clients will pay more for sustainable options, so we'll do that. So one of the things we try to accomplish by providing that bidding form up front is to understand what can you do from a carbon impact perspective, and how much is it going to cost, and what's the schedule impact, so that we can tie any costs related to schedule back to that too. So then we can take that to the client and say, listen, you can get, and Ian talked about the example, 10% doesn't cost you any different. It's basically standard practice, away we go. 20% is going to cost you, let's call it 2% more on the concrete supply, which translates to not even a fraction of a percentage on the old building. Does it make sense to you, client? Yes or no? 40%,
reduction, it's gonna cost you, I don't know, 20% more on the concrete supply. Does that make sense? Yes or no? And so that's how we change that conversation from the assumed green premium to what it actually costs extra, because, you know, in when we get to really deep reductions for the cement industry to get to zero, when they need to implement multi-billion-dollar projects on their plants, right? So that is going to increase costs somewhere down the line, but let's get used to that conversation so we understand and start to value carbon as part of the performance metric.
Yeah, just from the supplier's perspective, again, I come back to where LEED was several years ago, that people were asking, well, what's a green premium for a LEED silver building versus a certified building? It's like, well, over time, there is no premium because that's just how things are done. And yes, there may be premiums for certain reductions, as Jolene was saying, for specific projects, but over time, the expectation is that those green premiums will go away, excluding the sort of big elephant in the room around CCUS, which is, as Jolene said, multi-billion-dollar projects that the entire industry needs to get our head around as far as how we actually implement those projects and what impact that's actually going to have on the cost of a product like concrete.
So the one thing I would add, like we're having the same discussions, but we're trying to also add in this value component. So what is the value of the reduction on the overall benefit for the project? So there can be a cost, but is that the least cost impact of the other components for the project that we're looking at in terms of having an impact on the total carbon story for projects? And as soon as we start framing and understanding what the client's overall goals and aspirations are, then we're able to come back with a value proposition to help them navigate through their own decision making.
Yeah.
Cost can scare anyone with anything. And that quite often is the first thing they land on.
But I think that also is the point of putting the cost to the carbon, because now we're seeing clients who also have these science-based targets, who also have to make these reductions, and paying for offsets or addressing that, you know, to their investors comes at a cost too. And so now we start to normalize the conversation.
Yeah, and to Ian's point, to both of those points, if the conversation is just about cost, that's the wrong conversation to be having, because if you've got to look at the entire value chain or the entire structure lifetime as to what the best decisions are going to be for building that particular structure, and that those decisions need to be made obviously before the structure is built, because if you make a decision just on cost, you may actually be building something that doesn't have long-term longevity, and you end up having to have substantial costs associated with maintenance or refurbishment, rebuilding, you know, all of those sorts of pieces over the life of the structure.
Matt, can I ask?
I'm gonna cut you off there, Yuri, because we've got 2 more questions. All right. Can I cut you off, or is it super quick? Super quick
question. Example for, you know, given there's no schedule implications. Should we expect more costs for mix that has 30% supplement material versus 20%?
It's going to depend. So the question, does it cost more for a 30% SCM mix versus a 20%? It's going to depend on what the SCM is, where it's coming from.
Same. Oh.
So I sometimes it may cost less. Sometimes it may cost more. It depends on a number of factors.
Developers love those types of responses. In my experience. This one's going way deep for you, Neil. And I'm quoting here: the EPD published by Lafarge does not differentiate between the GWP, global warming potential intensity, based on certain concrete mixes. Therefore, when the team calculates carbon savings, it can only be done using the BC industry-wide EPD, correct? It's just a yes or no, Neil. It's just a yes or no.
I think I might have to read that question to understand what the question actually is.
Yes, we might have to get back to you on that one. I read it again and it confused me more, actually, the second time I read it.
Okay, yeah, I think I might need to take that question offline because I'm not exactly sure what the question is getting at.
Right, and you don't have the EPDs for Lafarge memorized for you right now? I mean, I thought we prepared for this panel, Neil.
Yeah, there's a few hundred.
Okay, this is another really specific one, but I'm going to give it a shot anyways. First of all, thanks panelists. Have you considered the geopolymer binders as recommended by Professor Davidots in the real alternative to carbon intensive Portland cement? If so, what are these? What's their performance with this binder versus a geopolymer binder in the embodied carbon?
Yeah. Anyone else want to take this?
Yeah,
The answer is square root of 2.
it is great.
42.
42. Nice.
So the questions around geopolymers and the use of geopolymers as opposed to using cement. For those people that aren't aware, geopolymers are a material they tend to be like cement, but are not cement. So they do require a chemical activator to make them go hard, like concrete does. Some examples of geopolymers would be certain fly ashes, for example, maybe a suitable feedstock for a geopolymer. Certain slags that may not be suitable for direct use in concrete, they may be suitable for use as a geopolymer. Or mine tailings. I know there's companies working on mine tailings for that now. As far as the long-term viability of those, a lot of those are in their infancy as far as their commercial viability. They are, if one of the reasons that concrete is the second most used material in the world is it's pretty much available everywhere. It's ubiquitous. When we start looking at some of these other materials like geopolymers, they tend to be much more regional as far as their availability goes. And that's some of the stuff that we were talking before about the availability of fly ash or slag. So those geopolymers tend to have very limited regional availability. So it's not going to be a sort of silver bullet that's going to fix the problem, is just switch over from cement to a geopolymer, because it's just not at the moment practical.
Great. I have one actual really good, well, there's actually some other good questions here too, but I got a good one that's answerable here in the chat. And it's, do the panelists foresee more projects moving to design build rather than design bid build in order to allow for the necessary collaboration with all parties?
So I know for EllisDon, the guy who leads our design build team at some point, like 15 years ago, started with that group and then eventually went back to the CEO and said, listen, I need bigger scope of work. I want to deal with more. And the CEO said, but you used to be 2% of our business. Now it's 40. We continue to see that increasing. And I do think it is the best opportunity to bring everybody in together. There's a lot of effort in the market to go to integrated project delivery models, which can have that same opportunity. But a lot of times those contracts still end up with this conflict-based finger pointing situation. So unless you change the culture of how you approach the project, the contract form doesn't really matter, because the contract is just there to protect everybody's butt, and we don't want to do that. We want to work together. So my opinion, yes, design build is going to be bigger.
I would actually go back to what you were saying before. It's actually about the relationships that you build with professionals in your team. And so we work on multiple different contract types. Some of the more successful ones we've had with contractors, CCDC 5A, 5B, where they're brought in much earlier in the process. And then we're working with an integrated team. We're not doing IDPs in its truest form, but it's that whole idea of breaking the barriers and actually having discussions from the outset of projects.
Yep.
So yeah, we are seeing a lot more design build, but there are different ways of skinning that cat. It's about having the conversation early. So get out your silos.
Yeah.
Go and have a conversation.
We've been talking for 2 years now.
Yeah, it takes a while to develop these relationships. So start now.
Yeah,
Right.
we're all friendly, just saying.
Mostly.
Okay, well, I think I might hold it there if we're at quarter after. Caroline, is there anything you want to come up and say to thank our esteemed panel here and for all of you people coming out today?
Thank you. Yeah, I don't want to say very much. I won't keep anyone any longer. I just wanted to say thank you very much to our panel who really kind of encouraged this in-person event. So thank you for getting us all together and for sharing your knowledge with us today. I think everybody here learned something. And there were a couple of questions. One thing we probably didn't mention was that the guide is available to download from the CLFBC website. So if you haven't read it yourselves, please do go and take a look when you get back to the office today. And if you liked this event and you want to come to more events like this, please do subscribe to our newsletter and we'll send you event announcements to your inbox. So yes, thanks again to our panelists and our facilitator today. Really appreciate it. And thank you all for coming down. I hope you had a good time.